So we've already been talking about dividing polynomials. We divided long division. We divided using synthetic division. Now what we're going to do is we're going to talk about the remainder theorem. So looking at the remainder. So what's the remainder? You're probably thinking, well, why are we interested in the remainder? We will see later on why we're interested in the remainder as we go along, okay? But this is what the remainder theorem is. Theorem, that means it's already been proven. So theorem, remainder theorem, when a polynomial is divided by binomial of the form x minus a, okay, we've already seen something like that when you have a polynomial is being divided by a binomial x minus a. Here's the thing, the remainder is p of a. So what does that mean, p of a? It means that whatever your polynomial is, we're going to replace the x value with the a value. Okay, so this means that we replace x with the value of a in the polynomial, and the number we end up with is the remainder. Okay, so that's why it's called the remainder theorem. So let's take a look at example number 1. Determine the remainder when 2x to the fourth minus 5x cubed minus 5x squared plus 5x plus 3 is being divided by x minus 3. Okay, so this part here, which one is this? This is the polynomial p of x. So this is the polynomial p of x. So we want to divide it by x minus 3. What does that say? What we need to do is replace the x with the a. X minus a. So what's the a value in this case? Okay. Positive 3, right? Okay, and going back to what Hassan had said, you can go x equal to 0, like a linear function, and whatever x is equals to. So our a is equal to 3, right? 3. So let's try that. P of 3. So this is p, and we're going to replace the x with 3. So what would that look like? So 2 times 3 to the fourth minus 5 times 3 cubed minus 5 times 3 squared plus 5 times 3 plus 3. Okay? Plus 3. Okay. Now that we've replaced the x with the a value, which is 3, we are just now going to evaluate this, meaning the word evaluate means find the value of. Okay, so p of 3 is equals to orders of operation, right? So 2 times 3 to the fourth. 3 to the fourth is 81. So 162 minus 5 times 3 cubed. So 3 cubed is 27. 27 times 5. My brain is not. I'm going to be a lazy thing today. I don't want to do long division in my brain. 27 times 5. 135. Okay, so 3 cubed means 3 times 3 times 3, so that's 27. 27 times 5 is 135. Now, minus 5 times 3 squared. 3 squared is 9. 9 times 5 is negative 45. And then 5 times 3 is 15 plus 3. And then P of 3, now it's just really nice, 162. Okay. Oh, I got a 0. Did you get a 0? Yeah. Okay, good. So that means what? What did we just do? It means that if we take this polynomial and we divide it by the binomial x minus 3, the remainder is 0. Okay, that's why it's called a remainder theorem.
Minus 30 or minus 0?
Let's try it again. 162 minus 135 minus 45 plus 15 plus 3. I got a 0. So we'll try it again. You added a 3?
Yeah, we didn't add the 3. It's coming before 3 is 0. 162 minus 175 minus 45.
162 minus 135 minus 45 plus 15 plus 3. 0. Okay? So therefore, the remainder is 0. Now, what does that mean when the remainder is 0?
It is a factor of the divisor.
It's okay, I really like that. Hassan said, since the remainder is 0, then that means this is a factor of that. It divides evenly, right? Divides evenly. So there's no remainder. So it will divide evenly. So that means x minus 3 is a factor of that. Okay? That's good. Now let's give it a try. Let's try the other one. Okay. Let's try the x plus 2. We're still using the same polynomial, but we're now dividing it by x plus 2. And we wanted to do is to figure out the remainder. Okay, so what is the a value? X minus negative 2, right? So your a is negative 2. And somebody came up to me earlier and one of your classmates told me, it's like, so if I see a plus there, then it's going to be a minus. Yes? Yeah. Okay, so let's do that. So P times, yeah, P of negative 2. So you want to give it a try? Do it on your own, and then we'll compare our answers. What you get? Okay, so we have to do the orders of operation. So exponent first, and then multiply, right? So orders of operation, like we learned about BEDMAS before. So what I did here is I did the exponent first, so negative 2 to the power of 4. Negative 2 to the power of 4, that's going to be positive 16. Okay, I slowed things down a bit in here. And then negative 2 to the power of 3, that's going to be negative 8. Negative 2 to the power of 2, that's going to be 4. And then negative 2, that's it. And then from here, I did one line next. 2 times 16 is 32. Negative 5 times negative 8 is 40. Negative 5 times 4 is negative 20. And negative 10. And I got 45. So what does that mean? What does that mean? It means that when we take this polynomial, and if we divide it by x plus 2, we're going to get a 45. Okay? Okay. Now let's try the last one. X plus 1. Okay, so x plus 1 is the same thing as x minus negative 1. So our a value is negative 1. Zero? Zero? Okay, I'm not done. I'll get there. Yeah, trust you. I'll trust you. Or trust me, I'll now it's 0. So what does that mean? When you take the polynomial, the long polynomial, and when we divide it by x plus 1, the remainder is 0. Okay? That's good. So I'm gonna end here. We have